Welcome to Rges Algebra 1. This is lesson 12A. We're talking about 6.1 and 6.2. We're entering a new chapter called Quadratic Equations. So we've been working with quadratic trinomials and factoring them, and now we're going to learn how to solve quadratic equations. The first thing he has you do is to memorize the quadratic formula. Quadratic formula is going to be one way to solve a quadratic equation. But before we can learn how to use the quadratic formula, we have some more teaching to do. So right now, he just wants you to memorize it. And we say it this way: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So just say that to yourself over and over again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Learn to say it and learn to write it. And so that's all you have to do for 6.1. Become familiar with it. As I told you, what those a, b's, and c's represent are the numerical coefficients in front of a quadratic equation. This would be kind of a generic expression of a quadratic equation. The A, the B, and the C. This would be, if I set it to 0, what those values would be, and I would plug those in up here to figure out what the x is. But we'll be showing you how to do that later when you have a little more skill under your belt. Right now, I just wanted you to get a little context for what in the world this thing means. Okay? But there are other ways also to solve a quadratic equation, and we'll be discussing some of those in addition before we actually get to using the quadratic formula. Now, right now, the first thing, because in the quadratic formula, you'll notice that we have a square root. So we want to deal with understanding square roots a little bit. Okay. First off, you want to become familiar with your calculator. So you'll have to get out a calculator. Some of them operate a little differently. I use the one on my phone, and it operates just like the one he's talking about as he suggested. But make sure that you're plugging in for your calculator and make sure it operates in the same way, because sometimes you have to do things in little different orders on a calculator. So it's very important that you learn how to do this and you check all of your answers against the example problems. For instance, this one on my calculator, I would say 5 plus 7. I would just type in all those things. I would say equal, and then I would take the square root. And that's the way I'm going to get the proper answer, which is 3.46. You might have to do, if I'm rounding to two places, you might have to do it a little bit different. So it's very important, these example problems on page 216 and 217, do not skip over. Take out your calculator and make sure you are crunching them correctly. Okay. In addition, go ahead and practice a little bit to decide whether or not they're going to be rational or irrational. A rational number is going to come out on your calculator like a terminating or repeating decimal. Could be a whole number, right? Because that would also be terminating. So terminating or repeating decimal. So even though something like the square root of 56169 looks complicated and I can't do it in my head, if I typed that in and took the square root of it, it would be a rational number. Also, because the answer would be 237, so that's rational. Also, something that looks like 22.09, if I type that into my calculator, it doesn't look rational. It's certainly not going to be a whole number, but it will be 4.7, so that's rational. So we can't always tell by just looking at it here. I have to go ahead and use my calculator to calculate it. If it ends up with something like this, that is indeed rational, okay, as is this. But if I type it in and it ends up with something very long, a very long decimal that just keeps going, then that is irrational. So that's what they're asking you to do in 6.2 is identifying it. Now make sure you understand the order of operations. If I had something like 7, 9, I would want to multiply first, then say what it's equal to. Go 7 times 9 equal, then take the square root. If you have something like 7 plus 9, again, under the radical, do everything under the radical first and then take the square root. Okay, that would take you all the way up. Let's say, if I have, let me look at another one. If I have something like the square root of 3.7 times the square root of 9.8, I would do 3.7, take the square root, times 9.8, take the square root, equals. Okay, so make sure that comes out properly. Again, if you have something like 5 minus, order of operations is important, and that's why I'm going through a few of these. Do that subtraction first, then take the square root. Or you could type in, that's kind of complicated to do in a single step. You probably can. I don't know how you would do it. I would just simply do it this way. 25 minus 8 is 17, and I would type in then in my calculator 5 minus 17 square root. Okay. So go ahead and do through 31 by yourself. And again, I tend to do some of it in my head and some of it on the calculator, but definitely taking the square root on the calculator. Now, I'd like to talk to you about a couple more ideas. He goes over this in number 33 through 35, so you can look at that for more explanation. But these are two important rules. If I have the square root of two things being multiplied together under the radical, that is the same as, so the square root of a times b equals the square root of a times the square root of b. Same with division. The square root of a over b equals the square root of a over the square root of b. And he takes you through some exercises to prove that to yourself. Very important idea. Make sure you understand that. Now, on the contrary, however, the square root, these two are not true. The square root of a plus b does not equal the square root of a plus the square root of b. He takes you through an exercise to prove that to yourself. And the square root of a minus b does not equal the square root of a minus the square root of b. So works for multiplication and division, but does not work for addition and subtraction. Important ideas. Another important idea on the next page. This would be looking at the problems on number 36. I want you to be sure you're very familiar with these. Let's say I've taken the square root of 6 squared. Well, the square root of 6 squared, we would do what's under the radical first. 6 squared is 36, so that's the same as the square root of 36, which is 6. Now here, though, you might be tempted to just take out a negative 5, because negative 5 times negative 5 equals, well, I got lost in what I was going to say, but you want to simplify what's under the radical first. Negative 5 times negative 5 equals positive 25, and the square root of positive 25 is, notice, positive 5, not negative 5. Okay, so all of those should do fine. You're looking at number 36 in the textbook, following along, making sure you're very familiar with that, because it's a common mistake. So it does not the square root of negative 5 squared does not equal negative 5, it equals positive 5 right here. Okay, now notice then that if I have the square root of n squared, whether n's positive or negative, it equals the positive, or the absolute value. Okay, let's look. I guess that's all for this lesson. Go ahead and bring any questions to class.